In 2020, Jakarta experienced heavy rainfall and major flooding. Located on the northwest coast of Indonesia, the city is vulnerable to extreme weather and rising sea levels. As the world's most populous island and the largest city in Southeast Asia, Jakarta serves as the diplomatic capital with a population of over 10 million people. This population is projected to grow by over 18 million by 2100, resulting in a population density of around 13,000 people per square kilometer. This high population density, combined with the city's location at risk of sea level rise, particularly for the 1.5 million people who live less than 10 meters above sea level, puts Jakarta at risk of flooding. A 1-meter rise in sea levels could result in the flooding of 405,000 hectares of coastal land in Indonesia. Despite being the 16th biggest economy and the largest in Southeast Asia, its per capita emissions were 9.2 tons of CO2 in 2015, larger than the global average of 7 tons of CO2 emission. As the world's fourth largest emitter of greenhouse gases in 2015, Indonesia's emissions were primarily caused by deforestation and peatland megafires, as well as the burning of fossil fuels for energy, which has exacerbated the problem of rising sea levels. As climate change continues to worsen, the city of Jakarta will face increasing risks from rising sea levels and extreme weather events. Many residents of the city live in low-lying areas that are vulnerable to flooding and other natural disasters. In order to protect these residents, the government has begun implementing plans to relocate them to higher ground. However, this brings its own challenges, as the abandoned areas will need to be dealt with. Housing that are left abandoned will lead to mold growth and the spread of harmful fungi. It also attracts pests such as rats, which carry diseases and cause biological damage to the surrounding area. These factors can have negative impacts on the aesthetic value of the area, decrease property values, and make the area less desirable to live in. In addition to the physical challenges of relocation, there will also be social and emotional challenges for those who are forced to leave their homes and communities behind. Furthermore, as sea levels continue to rise, the transportation system has been severely disrupted, making it difficult for material and food supply delivery. This issue is compounded by a rapidly growing population. Therefore, by the year 2040, the government is considering renovation and repurposing the abandoned structures for public or commercial use, namely through the policies for improved land use and spatial planning, energy conservation and the promotion of clean and renewable energy sources, and improved waste management. The city heavily uses algae technology in combination with recycled ocean plastics to enhance the living conditions of local residents. By implementing a sustainable closed-loop system of algae production and consumption, the city is able to reduce its reliance on traditional energy sources and improve air and water quality for its inhabitants. Additionally, the use of algae and recycled plastics helps to reduce waste and pollution in the ocean, making it a win-win solution for both the environment and the local community. The redevelopment of the abandoned area, with the help of algae and recycled plastics, fosters sustainability in the area by providing a range of public facilities such as farming, transportation, recreational, and environmental education and research facilities. These facilities not only mitigate the effects of inundation, but also help to reduce the environmental carbon footprint. The implementation of a closed-loop system in these facilities helps to form a cohesive link between them, enhancing their beneficial influence on the environment. The system helps to bring about a more efficient and sustainable usage of resources, as each facility can rely on the other for exchanging materials. Consequently, the environment is positively impacted by this interdependent relationship. First of all, in order to address the environmental issues of CO2 emissions, water pollution, and food supply shortages due to overpopulation, the abandoned area will be redeveloped sustainably by introducing algae farming into the refurbished development. Algae can be grown indoors using plastic as a framework for its growth, utilizing either natural light or artificial light source. The curved structure of the plastic allows the algae to be grown in a compact space, making it a more efficient use of limited indoor space. This approach can be used in urban environments where space is at a premium. By combining recycled ocean plastic with locally sourced timber, sustainable solutions for capturing and conserving rainwater in a community garden can be created. The rainwater capture system is designed in a funnel-like shape to maximize collection. This approach not only reduces plastic pollution in the oceans, but also provides a reliable source of water for the garden and supports the local economy. The use of recycled materials also helps prevent harm to marine life and reduces the carbon footprint of the system. Vertical mezzanine structures encased in soil can be used in community parks to create multi-level platforms for plants, improving air quality and creating a healthier environment. These customizable structures can be used to create a variety of plant-based artificial landscapes. The algae at the bottom of the building are able to use sunlight to convert carbon dioxide and water into oxygen and organic matter through photosynthesis. This process, known as oxygenic photosynthesis, can help improve the quality of water by increasing its oxygen content. In addition, the algae can be used in the treatment of wastewater by removing pollutants and other contaminants from the water. Secondly, to support the larger-scale reconstruction and development of the abandoned area, transportation hubs will be constructed to facilitate the transportation of resources and support the establishment of algae agriculture. This will bring vitality to the area and attract more foreign population. However, ports and transportation facilities have a significant environmental impact due to their high energy consumption and carbon emissions. To reduce this impact, one solution is to use large algae-filled frames to generate clean, renewable energy through sunlight. Another option is to utilize algae as a biofuel for combustion, where the CO2 emitted from the combustion process is redirected back to the algae incubation chamber as a nutrient source. As the area is redeveloped, it will be important to provide social and emotional support for the people living there. Building recreational facilities, such as parks and community centers, will help improve community cohesion and support creativity. A multi-purpose space with a semi-translucent skylight made of algae and plastic provides an indoor space for the community to host various activities, while still allowing natural light to enter the space. This is necessary due to the flooded area outside. The algae implemented on the skylight facade uses recycled plastic as a container. By placing the facade on the roof, the algae receives maximum sunlight. For photosynthesis, the algae converts sunlight into energy and can be harvested frequently, producing little waste and providing a source of fertilizer or animal feed. A public lecture room within the redevelopment of the site provides a space for community members to gather and engage in activities that promote social and emotional well-being. These activities could help foster a sense of community and support creativity. The room also served as a gathering space for community events. Algae were implanted within the wall structure and create a breathable wall that actively consumes carbon emissions produced by indoor activities. This can significantly improve the air quality in the building, making it a healthier and more comfortable environment for people to gather in. In addition, algae also provide extra support for the structure of the building. This can help to make the building more resilient and less likely to experience damage from environmental factors such as strong winds or heavy rainfall, which are common in Jakarta. It can also be used to clean wastewater and as a natural disinfectant. In this case, algae is implemented within the walls of wet areas, where gray water pipes connect to algae chambers for filtration and water recycling. The outdoor communal workshops for ocean plastic recycling use a modular scale roof structure for easy installation and dismantling to adapt to different climates. The use of recycled translucent plastic diffuses sunlight, making the space comfortable for working and reducing UV lighting. The collected plastic from the ocean is refined in the workshop and is used as building material or art installations. Finally, to promote community sustainability and support the development of the area, it will be important to build facilities for environmental education and marine research center. These facilities can help advance environmental technology and promote environmental awareness among the community members, and will provide both technical and cultural support for the development of the area and its residents. The mesh facade on educational and research facilities serves a dual purpose. It provides ventilation and acts as a noise barrier. This creates a more conducive environment for learning and concentration. Additionally, the mesh collects water from the air, providing a sustainable source of water for the facility. The design of this structure promotes a balance between individual study and group collaboration. It is divided into smaller semi-private areas for individual work, but allows for easy communication and collaboration with others in the same space. This layout creates a dynamic learning environment that supports both individual focus and group interaction. Inside, the building features natural ventilation systems with strategically placed vents and vertical greenery that work together to provide a constant flow of fresh air throughout the space. This ensures that the indoor environment remains clean and healthy for occupants, while the vertical greenery acts as a natural air filter, removing pollutants and providing a soothing visual element. In addition, these ventilation systems help reduce the building's carbon emissions and internal temperature. The modular facade of the laboratory provides varying degrees of light shading. In addition to the facade, the laboratory also has algae windows that can be manually controlled to provide varying levels of light penetration. This allows for a wide range of light conditions within the laboratory, providing a versatile and adaptable space for scientific research. With these sustainable development measures in place, the future of Jakarta is bright. The abandoned area will be transformed into a thriving community with a healthy environment, supported by the transportation hubs and recreational facilities that have been constructed. The facilities for environmental education and research will promote environmental technology and awareness, contributing to the long-term sustainability of the area and its residents. As a result, Jakarta will become a model for sustainable development and a beacon of hope for the future.